So, today I want to talk to you about our explorative study, which is representing a first step in creating a new system managing human energy with music. It's an explorative study. It's going to have a lot of descriptive statistics. But before we begin, let me just start with a quick screenshot. This grainy still is from a movie scene, Sylvester Stallone's Rocky. If you don't recognize this, well, now you have something to do for the weekend. Here's a quick summary. It's a story about a boxer who tries very hard to become a champion. He does lots of one-arm push-ups and all that. And when he trains in these montages, the film plays energetic music. Gonna Fly Now, The Eye of the Tiger, the most famous examples of activating music, not just for the character, but also for the audience. We feel activated when we watch Rocky train. So I thought, no one's going to make a film about writing emails or spreadsheets with lots of emotion, but can we use the same effect as when we're watching Rocky to support knowledge workers in regulating their energy? And the advantages of a system which does this would be twofold. So, in general, supporting human energy by securing the resources needed to meet task demands can be used to help workers improve their performance. But they can also work prophylactically for mental well-being, such as burnout prevention, which is one of the greatest causes of absenteeism. And secondly, music as a medium can be presents many advantages. For example, unlike physical activity, it can function irrespective of the environment. Unlike light, it can be used in a shared space. And unlike smells, it can be dynamically adjusted in intensity. So one theoretical background for this study is the mood arousal hypothesis, which postulates that the beneficial effects of music on performance can be explained by emotional reactions. In one example we have here from Hugh and colleagues, they found that, and here's a simplified diagram, that arousal or activation was a much stronger mediator, so it better explained the effect of music on performance than variance or mood. So in other words, when we're talking about the effect of music on performance, we should be focusing on arousal and activation, energy, rather than mood. And when we're talking about energy, I just want to quickly touch on the construct of energy which we use in our studies. And this is based on the work by Quinn and colleagues of the integrated model of human energy. I won't go into it here because once I get started, it will take hours for me to finish, but I strongly recommend the original paper, and I also have a video explaining it on YouTube. I'll share the link at the end of this talk. So the aim of the study was twofold. So firstly, we wanted to identify use cases for an energy management system. What are the needed transitions in energy levels which users are searching for when they're using such a system? And secondly, we wanted to determine possible features for such a system, what should be integrated, and also what aspects of user diversity need to be considered when creating such a system. What we did was conduct an online survey of university students, and this happened shortly before their exam period, 2 weeks before they had to write the exam, so they were really focused on studying, learning for these exams. And we had quite a diverse sample with roughly around 3 years of experience studying on average. And we asked these participants how much if they had previous experience on using music to affect energy levels, and at least 3/4 at least somewhat agreed to the statement. Only 20 students strongly disagreed, and these were excluded from many of the further analysis. So let's talk about the procedure and the three methods which I'm going to talk about today. So first of all, and to answer the first research question, we used a pictorial scale of human energy, which was developed by Oliver Weigelt and Fabian Lembusch, which is subject of another talk. And we asked participants to rate their level of energy on this battery metaphorical scale here. And this had two situations. to two previous situations which they had. First of all, in a situation where they were dissatisfied with their performance during studying session, and at another point in time when they had used music to successfully manage their energy level and they had successfully used music to be at a stage where they were satisfied with their performance. And what's important to note here is that these are post hoc analysis, so they were retrospectively talking about the past. We framed the question so that they were talking about a typical study session in the last 2 weeks. So this is something that probably happened, so the best case happened very recently because this was the studying period. Okay, that's the first method. The second one, and for our second research question, we asked the question, how do users differ in their ability to use music interaction to help with their tasks? We developed here a scale based on the affinity for technological interaction, which was developed by Professor Funke, which has ties also to the construct need for cognition. And this tool which we developed included items such as, I tried to understand why I enjoy a piece of music, or I try to immerse myself in my music. So measuring the engagement with music. And finally, we asked users about their most used features and which features they absolutely positively wished they had. And these were open questions which we analyzed with a simplified thematic analysis and using bottom-up coding on a semantic level. So when our participants were dissatisfied with their performance, as seen here, they most commonly had a low or middling energy level, while once they were satisfied, they overwhelmingly had a high but not maximum energy level. But now if we look at the specific transitions between these, it looks like this. But what does all of this spaghetti mean? So firstly, we see that indeed the most common increase before satisfaction was from below to above average. However, we should also note that around 8% of participants didn't report a change. So that's the horizontal bars here. And this suggests that they may not have considered energy as a necessary factor in their satisfaction with studying. And finally, we had a handful of participants who wished to reduce their energy. So this could indicate that they wanted to avoid tense activation. So they interpreted the battery metaphor as also including energy which is at a distressing level, being tense, experiencing distress rather than eustress. So the takeaway from this slide, high but not extreme levels of energy are enough to bring satisfaction with studying, and around 10% may not necessarily want to increase their activation. Our music interaction scale had a good internal consistency, but was not normally distributed. In our exploratory analysis, we found, interestingly, a weak correlation between the scale and the absolute change in energy levels. So in other words, those who reported a deeper interaction with music were somewhat more likely to report a greater influence on energy levels through music. And finally, what are the currently used features which users mentioned? So we have 4 clusters. Firstly, we have playlists, which are either ready-made and categorized by genre or by specific function, or discovery playlists, which allow you to discover totally new music. We also have automation. So this includes similarity suggestions. So I play me more music like the stuff that I already like. We also have shuffle. So take my playlist and put it in a different order, so just have a little bit of change, and then an endless loop, play the same song again and again and again and again. Now I interpret this as a spectrum of novelty. So we have play music which is totally new, or a little new, or just not new but in a different order, and which is absolutely not new at all. On the other half, when we asked participants to envision new features, we had For example, state-based selection, so machine learning approaches, for example, which assess current energy levels or mood based on physiological measures or with behavioral measures, and which would then make a selection of music based on this state to increase energy level in the future. Now, this could be an indicator for the acceptance of a human energy-based music selection system. We also had automatic volume control. So when I have high energy, play low volume music. When I have low energy, play high volume music. And this could actually be an indication for a wish to get into a flow state with music. And once I'm in there, not to be distracted out of it. And thirdly, we have break support. So this is like using music to support an indirect energy management. So I would like an audio cue to tell me when I should do another activity, which could possibly then be like psychological detachment, take a break, or have a coffee, which could also increase my energy in another way. Okay, so before we get to the implications of this work, let me just let me address some limitations. So firstly, we recruited via a mailing list. While our invitation was addressed neutrally, our participants had possibly a predisposition for using music as a tool, which is not terrible especially for our objective. We are looking to create a system for people who want to use music, but this should also be kept in mind when trying to generalize the results. Furthermore, this first study addresses study situation, which may be more intensive than other knowledge work. Secondly, participants reported in an open question, four participants reported difficulty rating energy on the battery pictorial scale. Now, this may be because energy wasn't salient enough in the past, or the distance was too long, or whatever. But it could also be that the pictorial scale couldn't correspond to the mental models of energy. They did not find that the rating on a battery was applicable to this previous work. But there's some potential for future work here. So what are the implications for our human energy management system with music? So first of all, we should always seek to find a balance. For example, by avoiding extremes, this would also conserve resources. Some work on the mood arousal hypothesis similarly shows that moderately arousing tracks are the most beneficial. Also, we should regard music interaction as a trait. And while this was only a weak correlation, this should suggest that there may be more answers to be found in how deep interactions with energy increasing methods, perhaps in general, can be leveraged to support human energy. And finally, like I said, I interpret the features here to be related to differing levels of novelty. So novelty seeking is a personality trait, and it should be also considered in the design of human management systems. So, in summary, we conducted a study on how students used music on human energy to influence performance during their exam period. Students were satisfied with high but not necessarily maximal energy levels, and sometimes sought to maintain or lower energy, around 10%. Management systems using music should incorporate users' need for novelty and support deeper interactions. So, thank you very much for paying attention, and if you'd like to get in contact with us, we're looking forward to your emails. Thank you again.